Hi everyone, this video is on exercise 12C questions 3 and 4. So in question 3, I'm only going to do part A because all of the parts are exactly the same. You just substitute a different number in the final step. So we have the function y is equal to 3 root x and we want to find a gradient at these points. So in part A, we want to know what's the gradient of the curve at the point when x is equal to 4. So in questions like this, when you have an equation of a curve and you want to find the gradient at a specific point, you always need to differentiate the function first, because when you differentiate, the derivative equation basically gives you the gradient. You just need to substitute the x coordinate of the point that you want to find the gradient of. So always in questions like this, the first step is differentiating, and then the second step is substituting the x coordinate of the point that you want to find the gradient of. So in this case, we have the function y is equal to 3 root x, and as we discussed in previous videos, we want to write this in a nice form first before we can differentiate, because we want to write this in the form of x to the power of n. So root x can be written as x to the power of a half, and in this way we can easily differentiate this function. So the power basically becomes a coefficient, and then we write down x and then power minus 1. So that's how we differentiate these types of polynomials, and then we can simplify this. So it's 3 over 2 x to the power of minus a half. Okay, now that we have the derivative, we can then find a gradient at the point x is equal to 4. All we need to do is that we just need to substitute 4 into dy by dx, and that gives us the gradient. So when x is equal to 4, then dy by dx is equal to 3 over 2 times. Now I'm going to write x to the power of minus a half in a nicer form, although it's not necessary because we can use calculator anyway. So we can write x to the power of minus a half as 1 over root x, and but obviously we want to substitute 4 into x, so we can just write 4 like this, and this gives us 3 over 2 times 1 over 2, which is 3 over 4. Therefore the gradient of this curve at the point x is equal to 4 is 3 over 4. And for the rest of the parts, it just basically substituting different x coordinates into the derivative equation. So there is no point in repeating the same substitution. Okay, now I'm going to do question 4, which is a bit more interesting. Right, in the fourth question, we have the equation 2y squared minus x cubed is equal to 0, where y is greater than 0, and we want to find dy by dx. Okay, so this is important, but before that, let me remind you that when you see equations in this form, obviously in pure 2 you will learn an elegant technique called implicit differentiation, which you can easily differentiate this equation directly. But now for pure 1, whenever you see equations that are in the on familiar form, then the best thing that you can do is just rearranging the form that y is the subject, and then it's written in terms of x. So in this case, let's rearrange this and make y the subject. So it can be written as 2y squared is x cubed, and then y squared is x cubed divided by 2. And now we can take the square root of both sides, which gives us the square root of x cubed over 2. Now you might be saying, isn't plus or minus the square root of x cubed over 2? Now the answer is no, it's only positive square root x cubed over 2, and that's because y is positive. So the question has told us that y is positive, so it has only one solution, which is positive. Okay, now the equation is written in a nice form, the form that we are familiar with. Now remember that we wanted to find dy by dx, so we are now at a position to find dy by dx. But maybe before that, it's better to write this in an even nicer form, because again we want to have x to the power of n. So what we can do here, we can first let's split the square root. So we are going to have a square root of 1 over 2, which is basically a square root of, so it's 1 over square root 2 times then a square root of x cubed. Now let's keep 1 over root 2 for now, and then root x cubed is just x to the power of 3 over 2. Okay, now that we have this, we can now differentiate. So dy by dx is equal to 1 over root 2 times, now the power comes down as a coefficient, so 3 over 2 times x and to the power 3 over 2 minus 1, which is just a half. And yeah, so this is the derivative, and I mean, you can simplify this, but yeah, there are basically a few ways of simplifying this. I'm just going to leave in this form 3 over 2 root 2 x to the power of a half. And you can obviously rationalize the denominator, but I think the question didn't ask for any specific form. Yeah, you can just leave your answer in this form. All right, that's it for this video, and thank you for watching.